All right, we're going to walk through just a little Monopoly numerical practice problem here. This is pretty straightforward, but a good indication of the type of question you might see, and some more practice doing simple calculations and matching them to what you see on the graph. So the information we have here, the price and quantity columns, that gives us the market demand. From that, we can of course calculate our total revenue, and that's just going to be our price times quantity, and then our marginal revenue, the change in total revenue for each additional unit produced. And then from total cost, we can get marginal cost, and then of course from profit, we can calculate that from our total revenue minus total cost. And then the trick is to figure out, using the rule of profit maximization, assuming this is a monopoly firm, where is their profit maximizing quantity and profit maximizing price going to be, and then again, matching that to the appropriate diagram. So for total revenue, again, just price times quantity. So 6 times 0, 0, you sell 1 unit for $5, total revenue of 5. 2 units for $4 a piece, revenue goes up to 8. 3 units at $3 a piece, total revenue up to 9. And then revenue starts to fall. So we get that parabolic total revenue function. So we're selling 4 units at $2 a piece, total revenue 8, and then 5 units at only $1, revenue comes down to 5. So that marginal revenue, again, now we're tracking the change from one row to the next. So we produce, we go from 0 units to 1, revenue goes from 0 to 5, we add $5 to total revenue. From the first unit to the second, revenue goes from 5 to 8, so we add 3. And then finally for that third unit, revenue goes up from 8 to 9, so we add $1 to our total revenue. And then again, once the total revenue starts to fall, the marginal revenue becomes negative, so dropping from 9 to 8, marginal revenue is negative 1, and then from 8 to 5, minus 3. Filling out the remainder of the table, we're given our total cost. And again, thinking about our marginal cost, we're just tracking those changes from one row to the next. Each additional unit of quantity, how does the firm's total cost change? So when output is 0, total cost is not 0, right? That's going to be our fixed cost of 2. And then that first unit causes total cost to go up from 2 to 4, so we add 2. And then we see that standard increasing marginal cost due to diminishing returns, and it happens right away here. So for that second unit, pushes total cost up from 4 to 7, increases by 3, from 7 to 11, increases by 4, 11 to 16, goes up by 5, and then 16 up to 22 goes up by 6. So we get a straight-line, linear, increasing marginal cost. And then finally for profit, again, we're just taking our total revenue, subtracting off our total cost. So at output of 0, no revenue coming in, but we have to pay our fixed cost, so profit is negative 2. Output of 1, revenue of 5, total cost of 4. We come up with a positive 1 profit. Likewise for output of 2, revenue of 8, total cost of 7, so we got $1 left over. And then things start to go south pretty quickly, right? So for output 3, revenue of 9, cost of 11, profit drops back to negative 2, and then it only gets worse, right? So our marginal revenue is falling and our total cost is rising. That's going to be bad news for profit, right? So when output is 4, revenue is 8, cost is 16, we get a negative 8 profit, or $8 in loss. And then finally, when output is 5, total revenue is only 5, but total cost is 22. That escalated quickly. Now we're losing 17, so negative 17 for our profit. So given that information, now for part B in the question here, what will be the profit maximizing price and level of output for this monopolist? So we'll see this on the diagram in the next section, but remember that the profit maximizing solution for the monopolist is a 2-part problem. So part number 1, we find the optimal quantity, our Q star M, and we find that at the intersection of marginal revenue and marginal cost. So we basically just ask, where are the marginal revenue values equal to marginal cost? And we see, we see that's here at output 2, marginal revenue and marginal cost are both equal to 3. So our Q star M, the monopoly optimal quantity, is going to be 2 units. The second part of the optimization now comes in finding the price to charge. And again, the simple rule to follow is the monopolist is always going to charge the highest price anybody's going to be willing to pay, and that is going to be right off the height of the demand curve. So at quantity of 2, the maximum willingness to pay is that price value of 4, and that's going to be our P star M, the optimal price for the monopolist, given this information is the $4. Okay? So the next question here is to plot all of this on a diagram. Right? So show a diagram with demand, marginal revenue, marginal cost, Q star, P star, and as an extra bonus, we're asking to show the level of profit. And to do that, we need to add in the average total cost curve at the right spot. So I know there is a graph included in the little handout here, but that's for the next question. So it's good practice to go ahead and start with just a blank sheet to draw this out. So let's see if we can make this look halfway decent. So we'll have our axes set up here, price, quantity, and we don't need to plot out every single point, but we want to show things in the right relative position. So here's our demand curve, and we show our marginal revenue with twice the slope, right? So hitting that quantity axis at the midpoint of the demand curve, and we have that marginal cost upward sloping. And the first key point here is going to be this intersection, right? So that's going to give us the Q star. And then when we go straight up from there, that's the height of the demand curve. That's going to give us our P star. Right? Monopoly optimal price. So that was the $4, and the quantity was at 2 from our table. Now, the trickiest part here is to show the average total cost at the correct spot, right? To give us that profit level of $1 at quantity of 2. So we don't have a column here of average total cost at each level of output, but we could do the one relevant calculation, right? Just remember that average total cost is always going to be total cost per unit, or total cost divided by quantity. And when output is 2, our total cost is here at 7. So our average total cost is 3.5. So thinking about our calculation of profit, remember how we do that on our dollar per unit diagram, just like we did in perfect competition, like we've seen that before, right? It's price minus average total cost times quantity. So this is a good way to double check that we're doing things correctly, right? So we have that price of 4, average cost per unit is 3.5, and we're producing 2 units, so we're making a cool 50 cents per unit times 2 units, so that's our profit of 1, which is exactly what we had on the table. So what we need to do here is to show the average total cost equaling 3.5 when quantity is 2. And we can clearly, kind of eyeball this. The key point is that it's going to be below the price. Right? So we get that positive differential giving us positive profit. So average total cost will be 3.5 here when output is 2. So let's make this stand out a little bit. And again, we're not going to worry about exactly where every point is going to be, but we want to make it follow the rules, right, of average cost versus marginal, and that's the same as it's always been, right? So it's going to be that U-shaped curve, and it's going to keep declining until it hits the marginal, and then it's going to slope back up. So it should look something like that. And now, this area between price and average total cost out to our quantity, that's going to be our positive profit. And that's what we're asked to do in this section here, and that's what kind of tells the story of the monopolist here. So now what we see in what looks like a continuation of the same question is actually a separate question, right, with this graph, right? So given this graph, now what we want to focus in on is how the monopoly equilibrium differs from perfect competition and showing the welfare effects of a monopoly industry, i.e. the monopoly rent, the transfer of consumer surplus to producer surplus, and then that total deadweight loss. So if this was an exam, right, and you were given this blank graph, we would need to label everything and show the correct prices and quantities, right, in their relative positions. So we'll start off by noting that the upward sloping curve here really represents two things, right? It's the market supply, and it's, actually, let's do this. Since we're doing this in kind of two different worlds, competition and monopoly, under monopoly, this is the marginal cost for that one firm, for the monopolist. In perfect competition, this would be the sum of the marginal costs, right, of all of the firms in the industry. So for perfect competition, we're adding them all up. We're making a blanket assumption here that one firm isn't going to be any more efficient than the sum of a bunch of small firms. That may or may not be realistic. Just note that that is an assumption that we're making here, that we're not moving that curve under these two circumstances. And then, of course, our outermost downward sloping curve, that's our market demand. And then only relevant in the monopoly case is the marginal revenue here. So what we want to focus in on here is where a perfectly competitive industry is going to operate. That's going to be, in the long run, at the intersection of market supply and market demand. So that point is going to give us our competitive price, we'll call that PC, and our competitive quantity, QC. And then, as we just saw, the monopolist is going to start at that marginal revenue equal to supply, or marginal revenue equal to marginal cost point, and move up to find its optimal price. So the correct placing of the monopolist price, PM, is going to be here, the height of the demand curve, right above the intersection of marginal revenue and marginal cost, which gives us their quantity level, QM. So as far as those welfare effects, it operates really just like a tax, right? So if we imagine an industry starting as competitive and then one firm buys up all of the competition and it turns into a monopoly, consumers are going to feel that rise in price from PC to PM. So every penny more that they have to pay is lost consumer surplus. So that little green rectangle here is that quote-unquote monopoly rent, right, or the decrease in consumer surplus because of this monopolization. And then the other factor is total output is falling. So consumers have less access to the product, fewer units being bought and sold, as well as having that rise in price. So the welfare impact from the lost quantity, same thing with a price ceiling, a price floor, a taxation disequilibrium, there's going to be that deadweight loss. Right? So that's the area here bounded by supply and demand vertically and the change in quantity horizontally. So that's our deadweight loss. So if you can superimpose all that information on a diagram like this, you are going to be in good shape and be able to provide a little explanation as to what's happening there. And there you go. Hopefully that was helpful.